Welcome to Ask and Learn.
First, drawing PV diagram of diesel cycle. So, I am going to draw the PV diagram of diesel cycle. This diagram will be very helpful in solving the problem. So, draw it more carefully as I am drawing here. Here it is P and here it is V. Process 1 to 2 is isentropic compression and 2 to 3 is constant pressure heat addition process. So it is constant pressure heat addition process. 3 to 4 is isentropic expansion and 4 to 1 is constant volume heat rejection process. Now going forward and solving this problem, process 1 to 2, that is T2 by T1 is equal to V1 by V2 whole to the power k minus 1. So T2 can be written as T1 into R to the power k minus 1. So putting the value of T1 as well as R here and solving this, we get T2 as 971.13 Kelvin. Now going forward, process 2 to 3 can be calculated as, so first we will write the formula as I am writing here. So we can write it RC as this. So RC on calculating we will get 2.265. Now going forward and solving this, process 3 to 4, we can have this formula. So it is the formula for process 2 to 3 to 4. We can also write it as this. Now going forward we can write T2 by T4 as RC into 1 by R whole to the power k minus 1. So T4 is equal to 2200 into 2.265 by 20 whole to the power 1.4 minus 1. On solving it, we get this. So this is the value of T4. Now heat supplied Q in is equal to H3 minus H2, which can be written like this. So on putting the value here and solving it, we will get the value as of Q in as 1235.0414 kilojoule per kg. Now going forward, we can write heat rejected per unit mass is equal to Q out, that is U4 minus U1, which can also be written like this. Now putting the value here, so I am just putting the value and solving it, we get it as 450.566 kilojoule per Kelvin per kg. Now thermal efficiency is known as NTH. So the formula for thermal efficiency is this. So just put the value of Q out and Q in here and solve it. So on solving we get NTH as 0.635, which is coming as 63.5%. Now going forward we can write mean effective pressure, that is MEP. So the formula for MEP is this. So we will just put the value after calculating W net. So I am calculating W net here, which is coming as 784.44 kilojoule per kg. Also V1 is equal to this. So I am just putting all the value and solving it to get V1 as 0.885 meter cube per kg. Now going forward, we have mean effective pressure, that is MEP. So just put the value of MEP which we calculate earlier. So I am putting the value of W net as well as V1 and R here, and now solving it we get as 933.02 kPa. So MEP is coming as 933.02 kPa.